The key functions of an operating system mainly including three aspects. The one is to manage the resources such as memory, CPU, processes like disk. The second one is to provide an interface through which a human can interact with the computer. Like for a regular user, you have to use the graphical user interface to interact with the computer so that you can, finish your jobs, like start a window, like start a program, visit a website, or etc. Now, the second type of the interface is the programming interface. It's for the programmers. So if you want to make a program, you have to call some APIs, which is the application programming interface, so that you can allocate some memory, create a file, or read a file, or write a file. So these two types of interface are pretty common in the operating system. Operating system is an independent course in the computer science major. So in this course, we just give some brief concept and basic algorithms, used in the operating system. So in this part, we are going to talk about the memory management, process management, and the CPU scheduling, which are the three important functions of the resource management. First is the memory management. So the operating system needs to keep tracking of the usage of the main memory, of the physical memory. For example, if you want to run multiple programs, you have to allocate the memory to each of the program. So this is called the memory management. The memory management will decide which process or data to be moved into or out of the main memory. So this is called the allocating or deallocating the memory. Because according to the John von Neumann theory, all of the programs need to be loaded into the main memory so that the computer can execute the program. So before we actually want to run the program, you have to load the program into one dedicated position in the physical memory. Regularly, two different programs cannot share the same physical memory. The important concept is called multi-programming. So multi-programming is the technique of keeping multiple programs in the main memory at the same time. Of course, they should be in the different places in the physical memory. So in this case, if your system supports multi-programming, that means multiple programs can be loaded into the physical memory, and we can somehow execute them both. So this is an efficient way for us to improve the utility of the CPU. Because the speed of the CPU is pretty fast compared with the main memory and all the other resources. So if we can keep the CPU busy, so that's very important because we can finish more program. The second is the process management. And the process management is used to actually manage the CPU. Because we have learned how the CPU works in the previous lectures. Because the CPU is working in the fetch, decode, execute cycle. So the operating system cannot directly tell the CPU to work or to stop because the CPU is working in a cycle. So in this case, instead of directly manage the CPU, we try to manage the program instead. So we define a new concept called process. So a process can be defined as a program in execution. Because the program is a static concept, it's a group of instructions. We can store the program in the hard disk. But if we don't run the program will always be static. If we try to run the program, it's becoming live. So we call the live concept process. So the operating system performs process management to carefully track the progress of each of the process and all of its intermediate states. So a process has different states. And the state of the process can be defined by the program counter, the general purpose registers, the related portion of the main memory. So each of the process mainly including these three parts. We have explained the time sharing system in the previous video. So time sharing is a very important type of system. And this figure shows you what exactly is the time sharing. So this horizontal line is the time of the CPU. Suppose you have a CPU and the CPU is keep running, and we can split the CPU time into intervals. So how do we achieve multi-programming? Suppose this is the main memory, and we can load the program into different positions in the physical memory. So in this case, we have two different programs running, so we call it process A and process B. So the time sharing is just like this. So for the first time slice, we run process A, and then we switch to the second process. So for the second time slice, we run process B. So in this case, we are keep switching from one process to another. So if we define the time slice as a static length of time, for example, 100 microseconds, so each of the process will run for 100 microseconds. Because the CPU is running so fast that people cannot really feel the switching between different processes. So the people may feel like all of the processes are running at the same time. So we call it concurrent running. So this is the concept of time sharing. Different processes actually share the CPU time. Because for one CPU core, it can only execute one process at a time. So in this case, when the process A is running, the process B is actually not running. So a process have different state, right? Sometimes it's running, sometimes it's not running. So this is called the process states. So typically, a process may have different states. Like in this case, we have new state, ready state, waiting state, running state, and terminated state. So now let's look at the different states and the changing between different states. First of all, the new process will be in the new state, and then it will go into the ready state directly because it's ready for running. Okay, and in this case, suppose you have only one CPU and multiple processes. So all of the processes that are in the ready state will be waiting in the queue. So suppose this is P1, process 1, so this is P2, process 2. So both of the processes are in the ready state. And because you only have one CPU, so only one process can be chosen to run. Suppose in this case, P1 has been chosen to run, so P1 will change to the running state. The software module and the algorithm in the operating system who is responsible for this dispatching is called a dispatcher or CPU scheduler. And the algorithm to choose which process will be the next one to be executed is called the CPU scheduling algorithm. So when the P1 finish its time slice, it will be go back to the ready queue again. It will be waiting in the queue again and wait for the next round of the scheduling. Suppose during the running of the P1, if some input and output event happened, it will be interrupted. The P1 will be interrupted because the input and output I/O is pretty slow. So we cannot wait the P1 to finish the I/O. So in this case, we are going to move the P1 from the running to the waiting state. Because some slow event happened, we need to keep P1 waiting. And when the P1 releases the CPU, the scheduler or dispatcher will choose the next process to run in the CPU. So in this case, P1 will be waiting. And when the I/O event finished, the P1 will be wake up. So P1 will be wake up, and then it will go back to the ready queue, to waiting for the next round of the scheduling again. And suppose, the program finish all the instructions, it will go into the terminated state because, the whole program has been finished. So this is the changing between different states, and this is a pretty important concept. And besides the process scheduling and the process states, the CPU, the process management still have some other functions like the single user and multiple user support and single tasking and multitasking, like the foreground and background processes, the preemptive multitasking and multiprocessing. So the multiprocessing is different from the multiprogramming. Multiprogramming means you can load the different programs into the main memory, but the multiprocessing means you have multiple CPUs or CPU cores so that multiple programs or processes can be running at the same time. A single-user operating system allows only one user to run one program at a time, so it's called a single-user operating system. Of course, nowadays, most of the operating systems are multiple-user operating systems. So multi-user operating system enables two or more users to run a program simultaneously. A multitasking operating system allows a single user to work on two or more applications that reside in memory at the same time. A multi-processing operating system can support two or more processors running programs at the same time. Processors or cores. If a user is running multiple programs, so the one that the user is using currently is called the foreground program, and the others are called background process or background programs. So of course, the foreground process or program will be more important than the background programs. So in this case, the foreground processes will be allocated longer running time. So the CPU scheduling concept we have explained in the previous slides. So it's an operation that decides which process in memory to be executed next.